If anything, there's a greater likelihood that coffee is doing good things for you.
Right. And actually, in one of I get given a kind of an interview with a radio station. The highlight of their thing was, how can I cut back on coffee? And the first thing I said was, do you need to cut back? So for coffee specifically, overall, there's more evidence leaning towards the benefits.
We've got a great guest. We're going to be talking with Marilyn Cornelis, PhD. One of her specialties is studying the genetics of how we metabolize caffeine. So for the coffee lovers out there or people drinking those energy drinks who love caffeine and want to know, is it good for me? Is it bad for me? We're going to try to get some answers today. Hello and welcome to the Enjoy Life Healthier podcast. We've got an absolutely fascinating program for you today. We've got a great guest. We're going to be talking with Marilyn Cornelis, PhD. She is a professor at Northwestern University, and she is well known for studying the role of coffee and caffeine in human health. One of her specialties is studying the genetics of how we metabolize caffeine and how individuals, how we all may differently utilize or benefit or get harm from caffeine. So for the coffee lovers out there or people drinking those energy drinks who love caffeine and want to know, is it good for me? Is it bad for me? We're going to try to get some answers today. So Dr. Cornelis, welcome to the podcast.
Hello, it's a pleasure to be here. Thanks for inviting me.
I'm really glad you're here. So I am a person that for many years had 2 pots of coffee every day, and I never thought that I would be able to kick the habit. For some reason, at a certain point in my mid to late 40s, I started noticing that when I would drink coffee, it would start giving me palpitations. And that caused me to stop drinking caffeine. I haven't had caffeine or coffee, I drink decaf now, but I haven't had caffeine in about 3 years. And I was able to break the habit in just a matter of days. I had some headaches, but I've been okay ever since. So I know probably 9 out of 10 of our listeners are probably consuming caffeinated beverages on a daily basis or on a regular basis. So why don't we dive right in? I'll put it this way. Caffeine, good for us, bad for us, or somewhere in the middle?
I would say it depends on the person, but overall, generally, I think much of the research is suggesting that it's potentially beneficial. But as you already provided a great example of how you obviously noticed that you can't tolerate the amount of caffeine that you were consuming at the time. And so that's what's cool about caffeine, is that most of us are well aware of our personal responses to caffeine. Some people know when to quit. That's kind of, we naturally know how to titrate our system in order to get to maintain that stimulating effect that we like from caffeine, but also avoid the adverse effects. And that can be obviously learned over time, and we know that most people are well aware of it. In terms of genetics, is what I've done. We also see that kind of in a large population setting. For example, we've done genotyping for thousands of individuals, and based on their self-reported intake. Some might question the validity of our self-reported intake of foods or diet in general, but interestingly, coffee and caffeine are captured quite well because people are so habitual when it comes to caffeine. They generally know, especially coffee drinkers, they know exactly how many cups of coffee they drink a day. And so in the multiple studies that I've done looking for genetic markers of caffeine consumption, we've taken their full genome-wide data and looked for variants related to their self-reported intake, and we found that there were variants in the gene that metabolizes well over 90% of caffeine, and we found that obviously for certain individuals they had a particular variant which was associated with much greater intakes. So that was one study. In another study, we looked at these genetic variants and the actual caffeine that circulates in the blood. And we found that the same variants were also linked to circulating caffeine. But what was interesting is that the variants that were associated with increased caffeine consumption were associated with lower levels of caffeine in the blood. And that told us is that these individuals, although they self-report consuming a lot of caffeine, they're metabolizing it so quickly. That's why they're consuming more. So that's just kind of evidence that we're naturally titrating our consumptions based on our personal responses to caffeine in order to get the psychostimulant effects of caffeine. Because literature has shown that while some of us might say that, oh, I like coffee because of the way it drinks, for the majority of individuals, we're consuming caffeine and the amounts of caffeine based on the way it makes us feel.
What percentage of people do you think are the fast metabolizers? Do you have any idea?
Well, we've identified a number of genetic variants, and so I guess maybe about half of individuals. It's like a bell-shaped curve. There's going to be people on the extremes, and then a lot of people in the middle, kind of metabolizing caffeine about the same amount. But there are some extremes, and I think all of us are well aware of, or can think of someone in our life that consumes way too much coffee. Wow, that's like, I could never consume that amount. It just shows you there's much in between person variation.
So if you're a slow metabolizer, what is the impact of caffeine on someone in that boat?
Well, they could drink maybe 1 cup of coffee in the morning, and they can kind of ride the caffeine effects all day. They won't feel the need to consume more caffeine later on. That's why you had these people say, "Oh, I'll have 1 cup in the morning, and I'm good to go for the rest of the day." They might just have slower caffeine metabolism.
So someone who is, say, a slow metabolizer, because there's a bucket of symptoms, I think, if you ingest caffeine that you could have. Like I said, I get heart palpitations. Some people get maybe jittery or nervous. Other people get insomnia. Would someone who's a slow metabolizer deal with all of these symptoms? Some of them, one of them? Did you look into variation within the slow metabolizer groups?
No, we didn't look at that, but I think as we mentioned, over time, we learn our responses to caffeine, and people know when to cut off. It's like, I can't have any more caffeine after 6 p.m. They just generally know. It's what's cool about caffeine. It's one of the most widely consumed psychostimulants in the world. It's a drug. And because it's so widely available through coffee, teas, obviously different doses, we generally kind of learn our responses to it. And usually if people are experiencing jitters, they're like, oh, I need to cut back on caffeine. And so, for next time, for say the next day, they'll know that, okay, yeah, I know my limits. Yeah.
So when it comes to caffeine, I guess people, and I'm thinking now of the energy drink market as opposed to coffee, although, coffee would certainly be part of this, but a lot of people use caffeine to study, to focus, as a pre-workout to get, energized. Have you looked at data looking at caffeine as a performance enhancer in any way in any of these categories?
I've not looked at that personally, but the literature would obviously we know that caffeine is a psychostimulant. One of the debates about how it's functioning is that maybe people perform better on it because when they're not on it, they're going through these withdrawal symptoms, and we're only consuming caffeine to avoid those withdrawal symptoms. But if in clinical studies where they've taken individuals who've abstained from caffeine for well over a week, they've kind of gone past those withdrawal symptoms, which you described yourself in your experience. Once you get past that point, you're fine. You're good to go. But in these clinical studies where they've taken those individuals who have completely been abstained from caffeine, then they give them caffeine again for the first time, they do notice an improvement in their cognitive function. So, for example, your reaction time and things like that. So there's definitely literature supporting that stimulant effects of caffeine. In terms of sports performance, it's one of the most well researched in terms of sports performance, and it does. I believe specifically it allows you to work out longer.
Uh-huh. What about like in-game performance? Would an Olympic athlete, like say a sprinter who chugged, an energy drink, do you think that they would have some sort of unfair advantage?
I Oh, it's actually I should know this because I know some, like the Olympic committee. I don't think they banned. I don't think caffeine is on the banned list,
No, it's not, it's not.
right? So just
Yeah.
because it's probably something that's hard to ban, and you can get and all athletes have eat. There's no discrimination. They can all get some access to caffeine. It's relatively cheap, right? In any
Right.
form. So that's well, we know that it does. Well, I guess some people don't need it. Some people feel they do. I guess it again, like it probably just depends on the individual. But again, if they're using caffeine as a tool to enhance their performance, um, they again would have to go through that learning curve to know when does a caffeine kick in? Because generally, when we consume caffeine, it takes around 20 minutes to absorb it. And so I guess within like 20 minutes, you might start feeling the effects. How long you feel those effects again might depend on your genetics or other factors, which makes us all individuals. But generally, most of us start feeling the effects within 20 to 30 minutes.
Yeah, I was actually, that was my next question. Is there a habituation? Do people start to need more and more and more caffeine to get the same benefits over time? Or is it non habituating?
Yeah, there's evidence to suggest it that would support that we become habituated. So if we have 1 cup of coffee a day, then the next day we have two, and we could tolerate it. Eventually, we're going to require more of it in order to get the same effects. But at the same time, you can also um, cut back on your coffee and then kind of resensitize yourself to caffeine. So it's flexible. So those are things we can do. So let's just say you're working hard all week and you're just relying on coffee. Then you decide to take a break on the weekend. Then you're going to be super sensitive for Monday when you get right back in the office again.
Is it understood the mechanism of action by which caffeine works in the body? What exactly is caffeine doing to deliver these, the impacts that it has, energy and alertness and athletic all the different things? How does it work actually?
The primary mechanism, which is most well studied and is likely contributing to all these effects, is the ability of caffeine to block the adenosine receptors. So if we take the brain, for example, where we experience the psychostimulant effects, we have these adenosine receptors. There's different forms. One, there's the adenosine 2A receptor and the adenosine 1 receptor, and there's also adenosine 3 receptor, but it's not as sensitive to caffeine as the other ones. But the adenosine 2A receptor, when caffeine latches onto this or blocks that receptor, the natural actions of adenosine that circulates in our body, that those the actions of that neurotransmitter is no longer effective. So adenosine is naturally induces sleep and also other things in the body. And when caffeine blocks that, the actions of adenosine, it contributes to the psychostimulant effects.
So for people that use caffeine long term, and I think a majority of people probably do, you may know the statistics better than I do, but almost everybody I know drinks coffee habitually, and 9 out of 10 of those people are drinking caffeinated coffee as opposed to decaf like I do. Are there long term health risks for drinking coffee habitually? Month after year. What is drinking coffee over the course of 30 or 40 years, like so many of us have? Are there consequences?
So for coffee specifically, I believe the consensus overall, if we take into account all the health, obviously there's so many different diseases and health issues. Overall, there's more evidence leaning towards the benefits. More
Okay.
specifically, I'll give some key kind of well established. So I won't say it's proven because it's primarily based on associations, but one in particular would be diabetes. Coffee has been consistently shown in large population studies to reduce risk of diabetes. And what's also interesting is that we not only see the benefits with regular coffee, but we also see benefits with decaf. So
Wow.
you're in a good place if you're consuming 2 cups of decaf. You're doing well. And so that just points to the fact that there's something else about coffee, and that could be another topic that we go into, because I have some talk. I could talk about more about that as well. The other disease is Parkinson's disease. It's been regular coffee specifically has been shown to reduce risk of Parkinson's disease. And it's likely due to specifically for the impact the caffeine or the interaction that caffeine has with the adenosine 2A receptor. That particular receptor also binds or heterodimerizes or connects with the dopamine receptor. And the dopamine pathway plays a key role in Parkinson's disease. And so there might be that interaction that contributes to the reduction in disease risk.
So for Parkinson's specifically, and I bring that up because I think a genetic risk. I have my grandfather and his mother both had Parkinson's, and on the other side of the family. So that's something in the back of my mind. Is that more caffeine specific or coffee specific?
Caffeine.
Okay, so it's the caffeine. But the diabetes, you're saying there's some data that decaf might actually, that there might be other things in coffee, chlorogenic acids or other phenols or whatever, that could have some, we come from the supplement world, as you know, and there are supplements available out there that have some of these ingredients out there. I know they're used in the weight loss area, and, we're not going to get into that here, but, certainly there could be these other benefits with coffee. So you're seeing data for diabetes. Anything else in terms of health benefits for long-term use?
The other one is with moderate consumption, so maybe up to say 5 cups per day. It's been shown to be beneficial for heart disease and related outcomes. After there seems to be they call it like a J curve, where there's more benefits with moderate consumption, but then potentially
Right.
either no risk or maybe even an elevated risk with higher consumption. And that might actually be as what epidemiologists refer to as potentially for confounding. There could be something specific about those individuals, or we could be capturing people like yourself who have experienced these palpations. And so, but then again, they generally would have changed their coffee consumption habits. But something unique about those people who are consuming a lot of coffee, there might be other confounders. So maybe they're stressed out, because often drinking a lot of caffeine and coffee is often linked with a stressed out lifestyle, which has been a real issue for the much earlier studies of coffee, where we were showing that it had an adverse impact on health. But once we accounted for other things, because we know one risk factor for multiple diseases that's highly correlated with coffee and caffeine consumption is smoking. And we know smoking is obviously linked to a number of diseases. And so some of the much earlier studies were not were unable to really tweeze the difference between those particular risk factors. So,
what have they studied as far as age groups go with caffeine? Young people today, I have teenage boys, they'll chug down an energy drink like it's a soda. And these things are freely available on the market for anyone to buy and potentially abuse. Do teenagers process caffeine, or kids? Is there a research looking at, I guess my question is there research looking at the impact of caffeine on kids or teenagers?
That's a great question. And you having asked that, I'd like to, tell everyone that most of the research that we've done on caffeine and health, coffee and health, has been based on adults. We really don't know the impact that caffeine has on the developing brain of our youth. And that's where the issue comes into play when we consider these energy drinks. Because unlike coffee, which is generally often referred to as an adult drink, little kids aren't really because we naturally, as
Yeah.
humans, we naturally avoid bitter substances. So why are we drinking coffee? Well, because it has caffeine. We've acquired a taste, much like people talk about beer. Beer doesn't naturally taste good. It's just you acquire that taste because of other things happening. But
Right.
for kids, obviously coffee isn't. They're not going to market coffee to kids. What's interesting about energy drink is that they're sweet. They've added like most of them have sugar. The sugar is the thing that we know that is not good for you. But
Yeah.
again, it still has a caffeine, and we really don't know the impact that might have on on these younger people over time. The other thing about energy drinks is that the cans look so pretty; they're so bright, and that's an attention grabber for
Yeah, that's
kids.
good marketing. And what about older people? Are older people at any greater risk of adverse events drinking coffee or caffeine really than younger people?
Some of the literature suggests that um, as you age, we generally reduce our coffee consumption. Maybe they just become more sensitive to it, or it's not coffee per se. They're just not consuming enough liquids, and coffee just happens to be one of those. We know that we're always trying to get our seniors to consume more to keep hydrated, but that's unfortunately not always the case. But there's no evidence to suggest that after the age of 60 that suddenly that the 3 cups of coffee that we're used to consuming is suddenly really bad for our health. There's no evidence to suggest that.
By the way, I should have asked you this at the beginning. How on earth did you get interested or involved in studying this topic, the genetics of caffeine metabolism, and it's an interesting sort of niche area. How'd you get into all this?
It's a classic case of someone giving me a project and saying, "Yo, just go and do it." Okay. Well, sort of. I graduated. I did my undergrad at Ryerson University. They called it something else for some reason, in Toronto. And after I finished my undergrad, I really wasn't sure what to do. I didn't know anything about graduate work. It wasn't something that our family was used to. My family, I'm from a farming, from a family farm, and so it was really just farming, which is what we're kind of used to. We weren't really into the higher education thing, so I thought I'd check out what this master's program was, and so I was accepted into the University of Toronto program, and I met my supervisor there, Ahmed El Sohemi, and we talked about genetics and interactions with diet. And this was an all new area, a field of research. I was like, okay, well, I didn't know that our genetics can modify our response to foods and ultimately health. So I thought, well, this kind of sounds exciting. And so I joined the program, and that's when I was introduced to the idea of what we call now precision nutrition. At the time, I started my PhD in 2001, and there were a few people doing genetics and diet. And so one of our projects was my supervisor was very interested in caffeine, and we knew that the gene that metabolizes caffeine had genetic variants in there. So he came up with the idea that it's got to be some variation in this gene that modifies a response to coffee and then ultimately heart disease, which at the time was my outcome of interest. So we designed the study, and I spent hours and hours, a couple of years, genotyping these large data sets, individually pipetting and running the analysis. And we got our first publication, which was published in Journal of American Medical Association, which is a pretty big, high impact
Yeah.
journal. And
Yeah.
that's where we show the interaction with our genetics and heart and heart attack at the time. And it made a big bit of a splash. It was probably one of the first gene diet interactions that were published in a pretty high impact journal. And from then, I was kind of hooked on the area. And so after I completed my PhD with that focus, I wanted to learn more about genetics. And so I did a postdoc at Harvard School of Public Health with Frank Hu, who is now the chair of that department. And at the time, which is really cool, at the time I was transitioning from a postdoc, this whole new field of genetics was underway. We were able to analyze the full genome of individuals at a reasonable price. And so that's when I was introduced to the new technology and also expanding my research,
Mm.
identifying more genetic markers of caffeine consumption. So that's what really got me into it. And I personally at the time wasn't a big coffee drinker. I knew the effects of caffeine. I like the effects of caffeine, but I got it through Diet Pepsi was my favorite. Also a favorite of other postdocs in my lab. That's kind of funny. We're Diet Pepsi fans.
So, what are you working on now, or what plans do you have in the near future? Anything else on coffee or caffeine, or anything else?
Well, I recently published a paper looking at coffee and dementia, and what we found was interesting is that besides the risk of dementia, we were looking at pathological measures of dementia in the brain, and we found that although coffee was slightly kind of moderately or reduced your risk of dementia, we found that it actually was associated with lower levels of Lewy bodies in the brain.
So
And that,
what is, because I think a lot of people are going to be interested in this, especially our older listeners, the role of, and it's a great subject. I'm glad you brought it up. What are those?
Lewy bodies, they're aggregates of what we call alpha-synuclein that is in the brain that happens. Obviously, alpha-synuclein is I don't know how to describe it, a fragment, but it's in the body. But when it's produced and aggregates, it forms these Lewy bodies. And most people, when they think of dementia, they think of Alzheimer's disease, because Alzheimer's disease is a major cause for dementia. But interestingly, Lewy bodies are something quite unique. There's a different type of dementia. It's a Lewy body dementia. It's not as common as Alzheimer's disease, but it does obviously impact some individuals. One person, I forget, he was a comedian. He played in Mrs. Doubtfire.
Robin Williams.
Robin Williams.
Yeah.
He died with Lewy body dementia. And what's interesting about Lewy bodies specifically, it's also a marker of Parkinson's disease. And as I already mentioned to you, caffeine there's extensive data supporting the role that caffeine has in reducing Parkinson's disease. And so while we don't see a very strong impact of coffee and caffeine per se on Alzheimer's disease-related dementia, we're finding this link with Lewy bodies. And so it could be a particular type of dementia where coffee is more beneficial. And it might be Lewy body dementia, or that whole area of Lewy bodies.
Interesting. Have you explored, I know we were mostly going to talk about caffeine and coffee, and that's maybe your real area of focus, but have you studied, I'm just curious, any other foods or beverages and how genetic variations impact how our bodies utilize those foods or nutrients?
Well, we also looked at other caffeine behaviors. What was interesting, we know that caffeine is found in tea and also dark chocolate. And so we actually do find that the same genetics that are associated with coffee consumption also associate with kind of total caffeine intake. So it also associates with regular tea intake. But what's interesting is that it also associates with dark chocolate intake. Dark chocolate has a very small amount of caffeine, but clearly it's enough that we see the impact that genetics have as well. And interestingly, the other thing besides the amount of coffee we consume, we were also interested in looking at how genetics might modify how we prepare our coffee. What we found was that the individuals who have the genetics for increased caffeine metabolism also tend to enjoy black coffee more than tea or more than adding sugar or milk. They also prefer dark chocolate and not milk chocolate. So they probably acquired this natural preference for these bitter compounds, because when you think of bitter, because caffeine is, if you were to take the drug caffeine and kind of just dab at it and taste it, it's bitter. So we might have linked or correlated the bitterness of caffeine with those psychostimulant effects. And so we start to appreciate the bitterness of some of these natural sources of caffeine. So we thought that was quite interesting.
Yeah. That is me 100%. I would drink, and my decaf, I drink it black and dark and very rich, and very bitter. Like my wife, she can't even understand how I enjoy it, and I do happen to prefer dark chocolate. So yeah, that does make
Yeah.
sense.
Something that might be of interest is a couple years ago, I published a study that looked at what we call metabolomics of coffee intake. So there was a coffee trial that was completed in Finland, and you'll kind of maybe you'll laugh when you think of Finland, but in this trial, what they did was they asked these Finnish people to abstain from coffee for 4 weeks, and then they collected blood samples after 4 weeks. Then they were asked to consume 4 cups per day, and we took their blood after that. Then they were asked to consume 8 cups per day. At first you think, wow, 8 cups, that's crazy. But in Finland, 8 cups is quite normal. So after they consumed it for 4 weeks, we collected their blood again. And then this new technology, it's in the area of metabolomics, allows us to measure all the metabolites in the blood. And so we looked at the differences in these metabolites across those three different time points. And as expected, we saw the caffeine levels were clearly higher. But what was interesting, we found some other metabolites that we never kind of linked to coffee. One pathway in particular has been the endocannabinoid system.
Oh wow.
We know that with the I don't know, the legalization of marijuana and cannabinoids, there's kind of an interest in trying to understand that. So endocannabinoids are not like the cannabinoids found in marijuana. The endocannabinoids are what's endogenous, but they do act
Right.
at the same receptors as the cannabis. And so we found that I believe these endocannabinoids metabolites, they decreased with coffee consumption. And I'm not familiar with the endocannabinoids, so I reached out to someone, I believe in Alberta, an academic center there, and they were saying that often the endocannabinoids will decrease when you experience stress. So maybe the coffee going from 0 cups to 8 cups had a bit of a stress on the body, and so the endocannabinoids were changed. So that was
Interesting.
interesting, and that's something I want to follow up in the future, in addition to the Lewy body story. But I thought that was a particularly new kind of, with that really evolving new technology, where we were able to identify something new in coffee that none of us would have appreciated before. We know that there's no cannabinoids in coffee, but it was our body's response to coffee that contributed to
Wow.
these changes.
Interesting. Have you looked at the role of other stimulant compounds like theophylline or theobromine that you might find in coffee, and if those play a role in health or might not be healthy?
Yeah, there's great interest. I haven't looked at those ones specifically. Theophylline is more coined with tea, and theobromine is definitely more in chocolate. There's not much theobromine in coffee, so chocolate would clearly be the target kind
Okay.
of food to look at. Tea, the one, I guess it would be kind of, I think it's worth mentioning is theanine. It's an amino acid that's found in tea. And it's unlike caffeine, it has more of a relaxing effect. And often people might think that consuming tea, it allows you to experience a little bit of the caffeine, but also the kind of a relaxing impact that particular amino acid has. So that's what might be kind of why people might their experience with tea might be slightly different than coffee, because the theanine might counteract some of the stimulant effects of caffeine. That hasn't been really studied well, but it's more theoretically it could happen.
Any other interesting, shocking facts about caffeine or coffee that you picked up along the way that people would be surprised to hear, or that are of particular interest or noteworthy that you could think of?
Well, you had mentioned chlorogenic acid, and maybe it's worth mentioning that. Out of all food sources in the diet, coffee is the major contributor to chlorogenic acid, and they've shown in studies that this might actually underlies the benefits that coffee has on diabetes. Is that chlorogenic acid might have a beneficial impact on our blood glucose levels. It might help with sensitivity or insulin sensitivity. So that might be driving that impact. Chlorogenic acid, as you mentioned, is a polyphenol. And again, it might have not only antioxidant effects, but it might balance or have an impact on glucose levels. And if we pull in the genetics, what's interesting is that if for individuals who are very slow caffeine metabolizers and can only consume 1 cup per day, if we compare them to individuals who metabolize caffeine very quickly and can consume 5 cups per day, if you think about it, the individuals who are metabolizing caffeine very quickly are probably being exposed to a lot more chlorogenic acid. So unfortunately, all these people, they're naturally reducing their coffee intake. Unfortunately, they're not being exposed to all that chlorogenic acid, so they're missing out on it. That's where decaf might be beneficial. So if people are looking to really trying to target that chlorogenic acid, then maybe they might be consuming decaf coffee to reap the benefits or other benefits that are found in coffee, much of which we don't know a lot about.
So have you looked at all at tea yet, or really the focus has been mostly on coffee? Because a lot of people, I think there may be as many tea drinkers in the world as coffee drinkers. It's a whole giant other universe.
Yeah, well, most of my research is focused on coffee, and even the coffee trial in itself is coffee, and we're applying for
Right.
another grant that hopes to do another coffee trial. So far it hasn't been a lot of tea, and like obviously there's so many types of different teas. So we have green,
Right.
yeah, and often tea is defined by the fermentation. So green tea would be no fermentation, while black tea has been fermented, and the chemical profile of those teas is quite different too. So we
Right.
haven't collected sufficient data on even the types of tea because, there's even with the matcha tea, which is kind of a variation of green tea. It's also different. So, tea is just it's much more different.
Has anybody looked at the different variations within coffee? I know the teas might be radically green tea versus black tea versus matcha. They may be very different from one another, more so than, say, lighter beans versus darker beans that you might get if you walked into a Starbucks. They have different varieties. Do you think that there may be differences between different coffee beans, different types of coffees,
Yeah,
or there
definitely.
more or less that there are differences?
Yeah, there's chemical. The composition of coffee changes as we roast the beans. Take chlorogenic acid, for example. Light coffee, so the less roasted, has more chlorogenic acid. With the heat, it alters the polyphenol content. So there's more in the light roast. And in the dark roast, there's other compounds. So these Maillard reactions. So there's these Maillard type of chemicals that are found. They're naturally found in coffee as well, and they might also have antioxidant effects. So either spectrum of the roast, we're still getting some benefits of like the different chemical composition, and even the beans. So there's most of the coffee in America is based on Arabica beans, but there also, I think there's an increasing trend to use Robusta coffee. Robusta coffee actually has a higher caffeine content, but it's considered a lower quality bean. Although I think some people suggest it might taste, it just has a different taste. So that's obviously the difference between the different beans.
And any difference that you would know between drinking coffee black and drinking it with, say, milk or sugar? Has anyone ever looked at the impact of adding things to coffee in terms of health benefits or its effects or adverse effects?
Well, up until now, I think most studies actually didn't ask a lot about what they've added to coffee. Generally, it's just coffee. Some studies have looked to see whether, the people that have actually the studies that have actually queried about what they've added to coffee, they generally don't see a big difference. But how exactly, because I guess it's just so much variation how people consume it. Um, Yeah, because obviously the sugar we know isn't very good for health, and but often, at least with milk, when people add milk to coffee, I think maybe you can disagree, choose to disagree, but most people add only a little bit of milk. Sugar is questionable. My brother, for example, adds a lot of sugar to it. In Canada, when we go to Tim Hortons, some people will get what they call the double double, which is unique to Canadians. It's like double milk and double sugar. I don't know if people get triple, but we really don't know if if there really is a difference. Generally, I think generally if you add a little bit of milk, I personally add artificial sweeteners. That's a different debate. But that's how I like coffee. I just don't. I can get do. I don't think I add any milk to it. So I'm not a big coffee drinker. I only started drinking coffee when I came to Chicago because from the research, there's shown that there's quite other benefits of coffee that are besides caffeine. So if you're drinking coffee with a little bit of milk and maybe a little bit of sugar, honey, I think you'll be fine. It's definitely better than reaching for a regular soda or even some of these fruit drinks, which have a lot of or a lot of sugar. Sugar.
So as we close out, you're delivering some good news here. You're not going to tell anyone cut back on your coffee or avoid coffee or don't drink coffee. If anything, there's a greater likelihood that coffee is doing good things for you.
Right. I'm not like the U.S. dietary guidelines actually says that up to 5 cups of coffee per day is safe, if not beneficial. Coffee, dark, obviously black, preferably. But it's important to let the the listeners know that it's not a recommendation that they should be consuming 5 cups per day. If you're already consuming 4 or 5 cups per day and you're relatively healthy, there's no need to cut back. You provide a great example of you experience heart palpitations. That's probably one that was actually debunked by a recent paper in a high impact journal as well. That there's only a few people that might be susceptible to it, but that's probably the only reason that physicians might ask. That's the only scientific data suggesting that why a physician might ask someone to cut back. Because of those.
Let's explore that for a minute because it is personal for me. Of course, it could be the placebo effect in my own mind. Maybe I had random palpitations one time and then noticed it another time and correlated it with my coffee consumption when maybe it had nothing to do with that. So you're saying there's actually some research suggesting that there might not be a link between palpitations and caffeine?
Or not that has a significant clinical impact.
Okay,
But
so it's unclear,
right, yeah,
basically.
yeah, and there's
Okay.
only a few people, but those people, they generally know. But for, it, years ago, physicians would often suggest people cut back on their coffee. It's always, if in doubt, cut back on your coffee. But there's more literature suggests that that might not be the case. So if you're stressing out, thinking the majority of people think they always need to cut back on coffee. And actually, one of I get given a kind of an interview with a kind of a radio station, and their key, the highlight of their thing was how can I cut back on coffee? And the first thing I said was, do you need to cut back? If you're healthy and you're
Right.
fine, that's altering your coffee behaviors is probably one of the probably unless you're super healthy, your weight is manageable, you're getting exercise, coffee shouldn't be a huge priority on your risk factor list. There are obviously other things. So if you're consuming four
Right.
cups of coffee per day, it's fine. The only thing that we do know is that coffee also has what we call diterpenes. These are fats that are found in coffee. If you consume a lot of coffee that's not filtered, you might have high cholesterol. And that's been shown in trials years ago. So most of the coffee that we consume today is often filtered, but we're getting fancier with coffee, like espressos. Those aren't filtered coffees. So if you get your cholesterol checked and you're consuming a lot of coffee and you find out that your cholesterol is high, all you need to do is filter the coffee and it's solved. So that would be the only adverse effects that's addressable that I would advise to listeners. But if you're already consuming 4 cups of filtered coffee and you're fine, don't feel the need you need like to cut back because you ask people to cut back. Sometimes it can get people anxious. You ask someone, if they had to give up alcohol or coffee, most people would say coffee. It's harder to give up. It's harder to give up coffee. Most people are social drinkers, so they can handle giving up alcohol.
Yeah, it really becomes part of your
Yeah.
routine. One final question. Is drinking caffeine, well, coffee or really caffeine, something that people might be able to use to control their weight? Is there any research that you're aware of that's explored the role of caffeine in weight management?
Well, in terms of there's large studies suggesting that as you age, we generally gain weight, but some of these large studies have shown that coffee consumption or regular coffee might prevent that weight gain over time. So that could be some evidence suggests that coffee can be used as weight management. It can also curb your appetite, but that might not be the case for everyone. But oftentimes it does. Caffeine is also a fat oxidizer. So studies have looked at weight loss studies, I believe, or even just weight management studies have shown that while caffeine might not reduce your weight, it might not further reduce weight relative to a caloric restricted diet, but it might reduce the fat, because when we lose weight, we kind of want to target the fat loss, right? We don't want to lose muscle mass. So drinking coffee or caffeine might prevent that loss of muscle and might really target the fat because it's a fat oxidizer.
And, I won't speak of my own personal experience, but I know a lot of people who say when they drink coffee, it spurs them to have to go to the bathroom. Is there data that's explored the role of caffeine or coffee in, I'll just say it bluntly, encouraging you to have a bowel movement?
There's two things. Obviously, caffeine is a diuretic, and most of us will go to the washroom quite often afterwards. Some people, for coffee specifically, they know in the morning if they have their cup of coffee, they will have a bowel movement. Number two, it's consistent, and there's data suggesting that there are subgroup of the population who experience it time after time. And there is increasing evidence or increasing interest in looking at the role that coffee plays in bowel health, and so that could be and there's pretty good evidence suggesting that it could be good for you. And because you're drinking caffeine, the caffeine might act as a natural diuretic. Caffeine has also been linked to a reduction in kidney stones. Perhaps it has to do with the ability of caffeine to kind of flush the water out and just clean out your system, of your kidneys. So that might be some other benefits of coffee consumption.
Very interesting. Before I let you go, any final health benefits that you could think of that would encourage people to keep drinking that coffee?
Nothing further to ask. I think we touched on that.
Okay, great. Well, Dr. Cornelis, thank you so much for joining me today. It was a really interesting discussion and very positive for people who drink a lot of coffee. It doesn't look like there is that much to be concerned about. If anything, they're probably helping themselves out a great deal.
Exactly. Thanks for inviting me. I enjoyed it.